So you've probably all seen this particular list, the 50 fastest muscle cars of the 1960s. And everybody has their opinions on it. Well, it's kind of bothered me a little bit over the past couple of years, or intrigued me, and so I wanted to take you on a journey about how I think that this muscle car list should be adjusted so that it's a fair test. Follow along to see how we do it. Many of you have seen this list before. This list is awesome. That I know it's been around for a very long time, but it lists all of the magazines of the 1960s and the dates that they tested all of the hottest and fastest muscle cars, and it's really interesting to see the ETs that they actually turned. And this is like one of those lists that everybody uses, right? They all scour the list. Where did my favorite muscle car end up? Why was that one tested and not the other one, or whatever the case may be? And there's a lot of debates in there. I just think it's fun. I'm a numbers guy, and so, but something about this test has always, or this list, I should say, has always bothered me. And I wanted to answer this question for myself, and so I thought I'd bring you along for the journey. But one thing that bothers me is take a look at the gear ratio. So we're doing a drag race comparison for the fastest cars of the 1960s, and some of these cars are running some really tall gears, and some of them have really deep gears. A couple of these cars have 411s, the 69 Cyclone Cobra Jet. You got another 410 in the Super B 6-pack. But some of these other cars, this 68 Hemi Charger is running 323s. 323s in a drag race, and it's still, supposedly number 5 on this list. So I always kind of felt like, well, geez, I don't know if this is really kind of a fair, even the Cobra's a 354. The 66 427 Corvette's a 336, competing against cars that have 411s, and I think there's even one on this list that had like a 430. There's a 456 gear and a 4-speed with the 61 Impala SS. So instead of 456 is comparing against cars with 320. There's another one down here, a 71 GTX with 320s. So my question was, well, hey, what would happen if it was if they were the same, right? Like, if they all ran the same gear ratio, because some of these cars that are running 320s would probably be a heck of a lot faster with a set of 411s. And there's room for discussion on that. I can already hear the comments coming in. But what I did is I went ahead and I got the same list off of Muscle Cars Illustrated, and as you scroll down, here's the list. But I could get this data, exported this data off of the list and put it onto an Excel sheet or a Google Sheets. So we can manipulate the numbers a little bit and see if it's possible, if we can make this more of an even comparison. Now, the other question that comes into mind is, well, how Rich, how are you going to know what a gear change would be? It's up, there's a lot of variables there. And I don't know if you guys remember this article. I remember it from back in 1995 of Hot Rod Magazine. I studied this article, probably read it 20 times when I was building my first drag car, because the staff at Hot Rod just did the coolest thing. They took this Nova, and I think they're at the track for 2 days, but they took this Nova and they swapped in 4 different gear sets, all the way from 300s down to 457s. And then they did it again with a different torque converter. So the first torque converter they used was an 11-inch, like a breakaway, and then they went to a 10-inch with a higher stall. And a couple of really interesting things about it that I loved, and that is that you can see exactly how much the ET dropped with each gear change, but the mile an hour was really consistent regardless of what gear and what converter it had in it. And so this is really the only thing that I could find where I could say, hey, if we had an example and you have a certain ET and then you drop the gear, what could be expected, right? Every car is going to be different. I get that. Some cars may not be happy with the super deep gear, like maybe a 455 Buick or an old. That might put them over where they're comfortable as far as revs are concerned. How, like a Ford 289 would probably eat up a 457 because you got to spin those things to get them to go. So what I did is I took the math off of this, and I'll kind of walk you through how I came up with it. But basically, when you look at this first one, 300 to 350, so you drop a half a gear, right? And you pick up 0.35 of a second. And so that kind of gives us an idea of what we can expect a gear change. Now, what's interesting is that when we go on this car from 350s to 411, it's not quite as much, but it's actually fairly close. because it's 22.22 of a second for another half gear. We'll do the math on this, and I'll show you how I came up with my formula, and we're going to plug this into Excel to see if this might give us a little bit of an idea of what these cars might have been capable of, assuming that they were happy with a 411. And it, as I said, there's a lot of room for debate, which I'm sure there'll be a ton of it. Okay, so here's the math that I worked up for the Excel sheet, and I kind of wanted to show you how I came to this conclusion. But in the first part of the article, when they go from 300 gears to 350 gears, basically, so that's a half of a gear change, which gave them 0.35 of a second improvement. So if I want to isolate, get it down to a tenth of a gear change, I'm going to divide both sides by 5, and then that's going to give me every tenth of a gear change should net me 0.07 of a second. But the second part of the article, when they went from 350 gears to 411 gears, it was what didn't see quite the same improvement. So again, it's still a half of a gear change, but it gave them 0.22. So I'm going to divide by 5 again, and that's going to tell me that my 0.1 in that scenario gives me 0.044 of a second. Now every car is going to kind of act a little bit differently, and some cars are dropping, through different gear ranges. So what I thought I would do to make it a little bit, I guess, more cohesive, if you will, is I want to take the average. What does each tenth give me, right? So basically, when I take that and we take the average of 0.07 and 0.044, the average comes out to be every tenth of a gear change could give us 0.057 of a second. And so that is the formula that we're going to use on the Excel spreadsheet when we get back to it here. The first thing I'm going to do is I'm just going to take this column right here, and I'm going to bring it in just a touch as far as the decimal is concerned, just to make it easier to work with. Here you have the Cobra at the top, running on basically a 350 gear, 4-speed, 12.2. And the first thing that I want to do is I want to find out how much difference there is in the gears that it's running and a 411 set, right? So I'm going to come into this cell, and we're going to enter a formula just for fun. And I'm going to say 411 minus the gears that it's running, and this will tell us the difference, how much of a difference it's making, or how much of a gear difference it has. It's going to flow down for all the cars, and you can see here the math checks, because on this particular car, that Plymouth Roadrunner 446 pack, it was running 411s from the factory. So as you look at this column, there's a 0 change for that car because there is no difference. It was running a 411. But on the Cobra, which is easy to look at because it's at the top, you would have 0.6 of a gear difference because you take a 350 to 411's 0.6. Okay, so all that does is really kind of give us a little bit of a difference. Now, what we want to do is plug in our formula to see what kind of difference this might make. So I'm going to go ahead and put in this formula. Let's see here. So I'm going to do the difference in gear, right? And I'm going to make it so the math goes easier. I'm going to times this by 10. And then I'm going to times that by our formula, 0.057. I'm going to hit return. Okay, so right here, we're going to autofill it. It's going to go down the list. This is, if I was to change to a 411, how much of an ET difference, according to the test that Hot Rod did and the formula we came up with from their data, right? So in this example on the top, Shelby Cope, if we went to a 411 again, it would be just a hair over half a gear change. And if the numbers are correct, it would have picked up 0.324 of a second on the ET. Just to double check our math, you can see it's still flowing pretty well, because what I'm going to do is I'm going to come in here and we're going to make this a little bit easier to work with. So you can see the ET And you can see here that basically the 411s are not really changing at all because they already had 411s. The Biscayne here that was running the super deep gear set, it's actually showing that it's slowing down, which is exactly what we wanted to do because, you know, hypothetically that's what would happen. And so I'm going to bring it over one more. We're going to do one more formula just for fun. And I'm going to say, now I want to see what the difference was, right? So I'm going to the ET that it originally did, and I'm going to subtract the difference in the amount that I supposedly picked up. And we're going to autofill this. So again, using the top line as an example of our Cobra, it originally ran a 12.2 at 118 with a 350 gear set. So we would have picked up 0.32 of a second, and that would have put the car running at an 1188 with a 411 gear set. Is that realistic for a 427 Cobra? Yeah, I kind of think it actually is. You know, the next one, the Corvette, you know, ran a 12.8 with 340 gears, and that would have taken it down to a 12.37, and you can kind of see how the list flows. Now, here's the next interesting part that I really wanted to find out. So some of these cars are going to pick up more than others, right? Some of the cars didn't really change at all because they already had 411s, and other ones might have been running 320s. Maybe they picked up a lot. So the question was, now what does the list look like, right? So I'm going to come to this column here, and we're going to sort it, and I'm going to rearrange all of the cars from fastest to slowest, assuming that we've got 411s in here. Again, the Cobra is still there. So it's really interesting because all of a sudden, you know, this list starts to look a little bit... Okay, so what I did is I put the two lists side by side. On the left side over here, we have the original list as it was published in the magazine. And you can see the ETs in column D and the gears over here in column I. Again, this is the original fastest 50. And then right here, starting in column K, moving over, what I did is we reorganized the sheet, assuming that every car was running 411. So I took the gear section out because they're all 411. We have the new ET that we calculated in column W. And it's super interesting because the first two spots, the big block Shelby Cobra and the 66 big block Corvette, are still first and second in the fastest 50 list. However, by the number 3 spot here, you've already got a change up. Originally, they had the 69 Plymouth Roadrunner, and now we have the Cuda with the 426 Hemi. Supposedly it would run at 12.7, and you can see the Plymouth Roadrunner got bumped back to 5th place right here, and then sliding up into the next spot, instead of the Cuda being in 4th place, we now have the 70 Chevelle SSL S6 454. I think that that's appropriately suited with kind of those that group of cars there. And it went up one spot because it was in 5th, and then it moves to 4th. What's really interesting, though, is like this car right here. So 69 Camaro ZL1. The reason that it's interesting is originally it was running a 411, so this car didn't change. So you'll notice it ran a 1316 in the magazine, and it drops back clear down into here with a 1316, and it didn't change because it was already running a 411. So it dropped back quite a few spots here because a lot of the other cars picked up with the gear change. So some of them are pretty darn close. So, you know, this 68 Corvette with this 427 actually stayed in the same spot. And then you have the Roadrunner giving up a spot to the 69 Corvette, the L88. Buick actually kind of remains in the same spot, which is kind of interesting. And then you'll notice that from the Dodge Charger 500, it gives up its spot to the 73 Pontiac Trans Am Super Duty. And then the list kind of goes on here with the Pontiac Trans Am. You know, it moved up one spot.
But now in that spot, we've got the Dodge Polara kind of moving up the spot there, and then we're back to the ZL1. So super interesting kind of to see. Again, there's a lot of assumptions in here. The formula isn't perfect, but it was just something that I was kind of contemplating in my head. And it does tell a really interesting story. There's several really big upsets in here. You can even see, for example, the 70 Ford Torino Cobra used to be in the 16th spot, and I've got to find it dropped clear back down into 26th spot, which is really interesting. Because it was running a 390 gear, it wasn't given that much of an advantage by going to a 411 where the other cars really picked up. But there's a lot of big upsets in here. We might do another video on this list because I think there's a lot of different ways that it could be viewed. But I'll see if I can figure out a way to post this list, the two comparisons, where they can kind of be analyzed. If you're like me, I could spend probably an hour really analyzing this list and to see kind of what moved up and what moved back. But it's kind of an interesting thought process just to see what they would all do again if we could figure out what they would all run with 411s, assuming they would be happy.
So what did you think? Obviously, we understand a lot of things. Full disclaimers for all of the comments coming that we can already feel. Listen, the math isn't perfect. We understand that all the cars have a lot of different variables. Everybody has their personal preferences. But the interesting thing is, I think that this list has some really important shifting going on, and some of the cars that I think should have gotten the credit for being a little bit quicker, they might have moved up that list to the appropriate spots. Comment below and let me know what you think.